Hello, in this video we're going to look at how to plot a phase portrait in 3D in Matlab. So this is code that's similar to Sayama's example in code 5.2. Couple of reminders. I am in my current working directory of Math 195 Matlab. I've started the code here with some comments and saved it. I've saved it in that folder, so just make sure that your current working directory is where you've saved your file. Okay, so in this model we are going to make a phase portrait. We start off with x sub n and y sub n the same as we had in our previous example, which was code 5.1. What's new and different here is we've got a z variable, which is going to give us our third dimension. So z sub n equals negative x sub n minus 1 minus y sub n minus 1 plus z sub n minus 1. Our initial conditions are also a little bit different. X naught is going to range from negative 2 to 2 in increments of 1, and the same is true for y naught and z naught. Time equals 30 time steps, and again I've modified this from Sayama. So a lot of this code is going to be very similar to what we did in 5.1, so why not reuse some of that code? Over here I'm going to double click on code 5.1, and that opened that up here in my script editor. So I'm just going to scroll down to where the executable code starts, and I'm going to copy paste all of that into my new code for 5.2. And I'll hide my command window a little bit since we don't need that right now. Okay, so what do we need to change here? Well, first of all, we've got a new variable, which is z. So let's copy paste and add a new array, make it all zeros, and that's for z. What else is different? Well, our a, which is the initial conditions for x, that's going to increment in steps of 1. Same with b, and now we better have some for loop for z, the initial conditions for z. So I'll call that for c equals negative 2, incrementing in 1, ending at 2. And I'm just going to keep the indentation lined up, so I'll just tab this all over. Initialize x, y, and z. So we have x of 1, y of 1, and now we need to initialize our z variable. Let's keep tabbing over so we keep everything lined up. And you know, in Python it's very important to keep everything lined up. In MATLAB that's not important, it's just aesthetically pleasing because it's easier to understand the code. So there's our little for loop for n. What we need to add inside this for loop is the line or the equation for our z. So I'll copy paste that, and let's keep our indentations lined up so that everything is clear. Now we're going to plot x, y, and z, and since this is a 3D plot in MATLAB, we need plot 3. We'll hold on to that plot. We need to end our for loop for c, and again, you know, maybe you thought I was silly in the previous videos where I was putting comments in here for which for loop I'm ending, but that was really helpful because I was able to see that that end was for the loop with b, and I do need one for c. So when your scripts get really big, those comments can save you a lot of time in debugging. It's better to put them in as you write the code. So that looks pretty good. Let's save. Let's run our code. I'm going to clear our command window so it's not so messy, and I'll go up here, grab code 5.2 Sayama, and run. And we get a beautiful 3D plot. Now we could add our axes labels as well. One thing I'd like to show you, there is a rotate 3D button in the GUI, the graphical user interface. So if you click on that, rotate 3D, and give MATLAB a minute to catch up to you, you can click on the image and rotate it around, and that's a really fascinating phase portrait. You can see there's probably a fixed point there at 0, 0, 0, but we could determine that analytically. Okay, the last example I want to show you is based on Sayama's example code 5.3. And in this example, we're basically going to modify code 5.1. The only thing we're going to change here is the model. So the model is going to be a negative 0.5x sub n minus 1 minus 0.7 times y sub n minus 1. And then on the next equation, we'll have x sub n minus 1 minus 0.5 times y sub n minus 1. Okay, so we're just going to change the model. We'll keep everything else the same. So let's just copy paste those lines down here into the simulation. And I'll go up and grab the equation for y. Copy paste that into the simulation. I've saved this as code 5.3. Let's just clear all our variables, clear the screen. So that's a phase portrait, but it's pretty hard to understand what's happening in this phase portrait. I mean, it's not easy to determine whether we have a stable attractor or an unstable attractor, or really what's going on. So that leads us to do something different, which is called a cobweb plot, and we'll talk about that in our next video.